Hello and welcome to online lecture number 4 for Chemistry 1101 during the spring semester of 2020. In this lesson, we'll talk about gas laws. These are scientific laws, and as such, there are broad statements that will summarize many hundreds, if not thousands, of past observations. These are statements that are not trying to explain anything. And to work off where we ended our last lesson was that we looked at various ways of characterizing a gas, various ways that properties we can measure for a gas, the pressure of a gas, the volume of a gas, the temperature of a gas, and the amount of the gas. And the question we ended the lesson with was, if we had these 4 different ways of characterizing a gas, pressure, volume, temperature, and amount, is there any relationship between these properties of gas? So if I know one, does that tell me anything about the other? Or in order to fully characterize a gas, would I have to be able to measure each of these 4 properties separately? And so that's one of the main ideas from today's lesson. And so to do that, we'll look at many of these relationships in turn. So first is the pressure-volume relationship. And what we normally would do in class, we actually do a little experiment, demonstration, where we would hold the temperature of a gas and the amount of gas constant. I would vary the pressure on that gas, and then we would all observe to see what would happen, if anything, to the volume of the gas. And what we would find is that there is a relationship, and the relationship is an inverse relationship. That as the pressure of the gas increases, and pressure here is in millimeters of mercury is just another unit of pressure like atmospheres and PSI. In any case, as the pressure increases, we find that the volume decreases. Whereas the pressure decreases, we find the volume increase. So there's inverse relationship between these 2 properties. As one increases, the other one has to decrease. This is summarized by what's known as Boyle's law, which says the pressure and volume of gas are inversely related or inversely proportional to each other if the amount of gas and temperature of the gas are constants, if they don't change during the experiment. We can summarize Boyle's law mathematically a couple different ways. This is one way we can do that. It says that pressure is inversely related to volume, which says that if this number gets larger, volume gets larger, and because it's 1 over volume, then pressure must get smaller, and vice versa. Also, we can summarize it this way, where because they're inversely related to one another, their product, pressure times volume, must equal some constant, some number. But what that constant, what that number actually is, though, depends upon the amount of gas and the temperature of the gas. What's nice about these gas laws that we'll talk about today is that they have immediate real-world applications, sometimes very important real-world applications. And Boyle's law is certainly no exception. They actually understand how breathing works by an application of Boyle's law. That pressure and volume are inversely related to one another. So kind of keep that idea in mind, as well as kind of keep this idea in mind, where if we have air or any type of gas, and we have that gas or air at higher pressure adjacent to that same gas or air at lower pressure, then we can predict the directionality in which that air will flow. That air will always flow from the region of higher pressure to the region of lower pressure, and thereby try to equalize those dissimilar pressures. So those 2 ideas in mind, when we inhale, our diaphragm works to increase the volume of our lungs. By increasing the volume of our lungs, it's going to increase the volume of air inside our lungs. According to Boyle's law, if volume increases, pressure must decrease. And if pressure decreases, when we inhale, that means we have a lower pressure of air inside the lungs relative to the air outside our lungs. So according to this idea, air will flow from outside into our lungs, thereby we inhale air. Conversely, if you want to exhale, the diaphragm works in the opposite way by decreasing the volume of our lungs, decreasing the volume of air inside our lungs. If the volume decreases, pressure then must increase. And so as a result, we now have a region of higher pressure inside our lungs compared to a lower pressure outside our lungs. As a result, air will be pushed out. We can also explore the temperature-volume relationship, where I would do an experiment where I'd hold pressure and amount constant, I would vary the temperature, and then we would observe what would happen, if anything, to the volume of the gas. And what we find is a direct proportional relationship between temperature and volume. This is in contrast to what we saw with pressure and volume, where they're inversely related. Volume and temperature are directly related. As temperature increases, the volume also increases, or if temperature decreases, the volume decreases. And this relationship is summarized by what's known as Charles's law. That volume and temperature are directly proportional to each other, assuming the amount and pressure are constants. We can summarize it this way mathematically, that volume is proportional to temperature, which says as one increases, the other one has to increase. If one decreases, the other one has to decrease. Once again, considering under this disclaimer that we have a constant amount of gas and a constant pressure. We can also relate it this way, that if they're directly proportional to one another, if volume increases, if my numerator increases, the temperature, the denominator also has to increase. So their ratio is going to equal to some constant. And that constant depends upon how much gas we have and the pressure of that gas. The application here has to do with, one of the applications here certainly, is with hot air balloons, how hot air balloons work. We want to raise the hot air balloon to higher and higher elevations, and we can do so by increasing the temperature of the air inside the balloon. Because according to Charles's law, if I'm able to increase the temperature of the air inside the balloon, that's going to increase the volume of air inside the balloon. Why that's relevant is that by increasing the volume of air inside the balloon, if this number gets larger, that's going to make the density of the air inside the balloon smaller. And as the density of the air inside the balloon decreases relative to the air surrounding it, it's going to rise. Conversely, if we want to lower the balloon, we would decrease the temperature of the air inside the balloon, which would decrease the volume. Decreasing the volume would thereby increase the density. So we can very carefully affect the altitude of our hot air balloon by very carefully controlling the temperature of the air inside the balloon, because that affects the volume, and the volume then is going to affect the density. And finally, the last relationship we'll look at in this lesson is the volume and amount relationship, where we would hold pressure and temperature constant, we would vary the amount, and then we would measure the volume. And what we find is that as the number of moles increased, the volume would also increase. Or as the number of moles decreased, the volume would also decrease. And this is summarized in what's known as Avogadro's law, which says that the volume of a gas and the amount of gas are directly proportional to each other, assuming once again that the temperature and pressure, those other properties of gas, if they remain constant. So volume is proportional to number of moles. As one increases, the other one increases. As one decreases, the other one decreases. Conversely, we could also relate it this way or express it this way, where if they're directly proportional to one another, then their ratio must be a constant. And that number depends upon what the temperature of the gas is and what the pressure of the gas is. One of the many applications here, probably the simplest application, is simply blowing up a balloon. I want to blow up a balloon. I want to increase the volume of a balloon at constant temperature and constant pressure. Then Avogadro's law says to do so, I'll have to increase the number of moles, the amount of gas inside the balloon. So I push air inside the balloon, that increases the volume, according to Avogadro's law. If I want to decrease the volume, if I want this number to go down, then I have to also decrease the number of moles of gas inside the balloon by practically letting air out. And so what we've seen in this miniature lecture are these three gas laws. Boyle's law relates pressure and volume. They're inversely related to one another. Charles's law relates temperature and volume. They're directly proportional to one another. And then finally, Avogadro's law, which relates volume and amount, and they're also directly proportional to one another. So these laws by themselves allow us to, at the very least, relate qualitatively how the change in one of these variables, one of these properties, may affect the value of a different property. What we'd like to do, and what we will do in the next lesson, is combine these gas laws into actually an equation, which will allow us to equate, or otherwise, in other words, calculate quantitatively how the change in one of these properties affects the change in another, or how just simply the value of one of these properties allows us to perhaps predict the value of another property.